When we're trying to solve problems, we use algorithms in methods to break down the steps we need to take. We implement those algorithms in a computer using a programming language, like Java. In that process of writing code to implement an algorithm, we need some sort of structure to represent the different components or characters involved in our algorithm. Let's say I'm designing a program for a retail store that can both keep track of employees' hours and salary and record the items being sold. What are some of the things I'd need to keep in mind? Well, I'd need to have a structure to represent each employee, so let's start there. Every employee is going to have the same set of properties, or in other words, there are some common pieces of data we'd need to store for each of our employees. These are the attributes of our employees. Well, each employee has a name, so we could store that in a variable called name, but just to be more specific, let's have a first name and last name. Depending on what their position is, each employee will also have an hourly salary, let's say hourly salary. We'd also need to store the number of hours they've worked, so let's say if they're getting paid weekly, we could have hours this week. We'd also need some contact information so we can schedule them, so let's say phone number, email address, and home address. These are all attributes of our employee. Our employees also have certain behaviors or actions they can do that might end up changing their attributes. For example, an employee can clock in and start the timer for their new hours during their shift. This isn't an attribute because it's not a piece of data necessarily, it's an action. Similarly, there's another behavior, clock out. This would end the timer for their hours and then add them to the hours this week attribute. Again, clock out is a behavior. It's not holding a piece of data of its own, but when used properly after clock in, it updates the total number of hours worked during the week. We could also have another behavior, let's call it get paid, which could take the total number of hours this week, multiply by the hourly salary, and send out a check with the employee's money to their home address. Get paid could also set hours this week back to 0, restarting the hours they've worked since they got paid for all of their previous hours. Let me just emphasize again the difference between these attributes and behaviors. An attribute is a variable, a value being stored. A behavior is a method. It's an action that's taken that can both read values from attributes and write new values into them, like the clockout method changing the value of the hours this week variable. What we just built is called a class. Let's call it the employee class. A class serves as a blueprint for a group of objects that all share these attributes and behaviors. An object is a specific instance of a class. For example, let's say I had an employee named Ryan. Ryan is an instance or a specific case of the employee class, since he's a specific employee. The employee class is that general blueprint. Ryan is an object from that class. He's one specific employee made from that blueprint. Objects have defined attributes. Ryan, for example, has all of these attributes that are specific to him. First name Ryan, last name Singh, hourly salary $13.50, hours this week, let's say 36, and so on. Notice that although the attribute variables changed the specific values for Ryan, the behavior methods didn't. That's because the behavior methods don't store anything of their own. They're just actions, but they can use and manipulate Ryan's specific attribute variables as necessary. What if I wanted to make another employee? I'd be making another object, so I'd use my class, which again is really just a blueprint for making specific objects. If I had another employee, let's say Jackie, she'd have her own set of defined attributes, but would still use the same set of behavior methods. And if I had more employees, I'd keep using the class template to add them as objects to the program. So that's a bit of an introduction to classes and objects. Classes are blueprints that hold both attribute variables and behavior methods. Objects are specific instances of those classes, with their own specific attribute variable values. It's also good to keep in mind that there are different levels of classes. I previously mentioned that we'd want our program to also keep track of the items being sold. I could have a class named item with attribute variables of price and count to store how much it costs and how much of that item we have in the store. It could also have the behavior method buy, which would add its cost to wherever we're storing our revenue. The buy method would also decrease the count by 1, since now we have 1 less of that item. Well, item is pretty generic. All items have a price and count, but if I'm looking at t-shirts, those have sizes. Do I need to make another class separate from item for t-shirts? Well, no, I can make a class called clothing that inherits price, count, and buy from item, but also has type, size, and color attribute variables of its own. Clothing is a subclass of item. Here, I could make a clothing object which contains price and count from item and type, size, and color from clothing. For example, I could have 10 units of a blue, large t-shirt that's priced at $18. Similarly, I could have another class called home decor for things like furniture and paintings. If I wanted to go even more specific, home decor could have its own subclasses like furniture, lighting, paintings, and so on. Classes can inherit from one another. The superclass is like the parent, passing on its own existing attributes and behaviors. The subclass is like the child, which takes those attributes and behaviors and adds on more of its own. We'll get into the specifics of this later, but just keep in mind that classes can be derived from other classes. This is useful because we're increasing the reusability of our code. Instead of building things from scratch, we're building from existing classes. So hopefully that gives you a conceptual sense of what classes and objects are. Classes are blueprints for representing different things from our real world in our computer, whether it's an employee or a retail item. Objects are specific instances of classes, like Ryan, our retail worker, or our large blue t-shirt. Objects can represent both real-world things and abstract things, and they're useful because they store information of their own via their attribute variables and because they perform actions via their behavior methods. We'll see how objects in our programs can be used to interact with one another in a methodology of programming called object-oriented programming.